Okay, in this short video, let's do some exercise for section 2.2. It's on page 165. So first, find x, y intercepts. X, y intercepts. Let's see the first one. Let's try the problem 18. Y equal to x minus 6. Okay, so to find x-intercept, let y be 0. To find x-intercept, let y be 0. So you get 0 equal to x minus 6. You solve for x, you get x equal to 6. It is the x-intercept. And to find y-intercept, let x be 0. X is 0, so you directly get y equal to 0 minus 6, negative 6. It is the y-intercept. Okay, and that's it. So x equal to 6, y equal to negative 6. Okay, so let's try the other one, 24. Assume we have an equation y equal to negative x squared plus 1. Then what we have, so to find x-intercept, let y be 0. Y is 0, so 0 equal to negative x squared plus 1, so x squared equal to 1. X is equal to plus or minus 1. The solution of the equation x squared equal to 1 has 2, plus or minus 1. So they are x-intercepts. Okay, to find y-intercept, let x be 0. X is 0. Y say let x or let y be 0 means in the original equation. So you get y equal to negative 0 squared plus 1 equal to 1. Is the y-intercept. Y-intercept. Okay, so that's a way to find x or y-intercept. Okay, and next part, we find the corresponding symmetric point. Find the corresponding symmetric point. Okay, so let's check problem 30. Problem 30, assume you have a point 5, 3. Okay, now let's see the symmetric point with respect to x-axis is, okay, with respect to x-axis, x does not change, y becomes negative, the opposite, not negative, opposite. Okay, with respect to x, x does not change, y becomes opposite. The symmetric point with respect to y-axis, with respect to y-axis, y does not change, it change x, only change x. Y coordinate does not change. The symmetric point with respect to the origin is with respect to origin, you're supposed to change both to be the opposite. 5 becomes negative 5, 3 becomes negative 3. Okay, so you're supposed to change both. So that's a way to find the symmetric point with respect to the corresponding either axis or the origin. So for example, if we have 38, we have point -3, 0. Then the symmetric point with respect to the x-axis is, okay, with respect to x-axis, x coordinate not change, y coordinate change to be the opposite. 0, you give it an you add additional negative signs, -0. -0 is still 0. -0 is still 0. So the symmetric point is itself. The symmetric point with respect to the y-axis is, with respect to y-axis, y does not change. X coordinate changes to be the opposite. -3 opposite is 3. Okay, the symmetric point with respect to the origin is, you're supposed to change x, also change y. 3, 0. Okay, 3, 0. Okay, so that's the problem 38. Find the corresponding symmetric points. Very good. Next part, assume we have graphs. We're looking for the intercepts indicate the symmetry. Okay, so look for intercepts, determine symmetry. Okay, there are two situations. Let's check 40. Check 40. 40 has a graph like this. So this is number 1. With this graph in your mind, you see here clearly, you only have this piece, so you cannot add additional information. This is the only information you know. So there's only one intercept. There is only one intercept. This intercept is 0, 1. It's on the y-axis. X coordinate is 0, y coordinate is 1. So this only unique intercept is 0, 1. You can say the y intercept is 1. Or you can say y intercept is 1. Y intercept, it's the same thing. Okay, well, you see, what is the symmetry of this graph? If you fold it this way along the y-axis, they don't coincide. If you fold it along the x-axis, there's no the other part. If you do the rotation, also it's wrong. So it is not symmetric with respect to the axis nor the origin. So it has no symmetry at all. No symmetry at all. Okay? So this is 40. If you check 42, 42 looks like this. Well, assume it's very symmetric. This is a 1, 2. This is -3. So from this graph, you can check the beta graph in the textbook. There are intercepts. We're talking point. So here, this point, -2, 0. This point, 0, -3, and the right point, 2, 0. X coordinate is 2, Y coordinate is 0. It's on the Y is like the height. It's on the floor, so the height is 0. Or you can say x-intercepts are -2. This is the equivalent one. The statement in the parentheses is equivalent to the above statement. So all you can say this: x-intercepts are -2 and +2. Y-intercept is -3. This is also equivalent to this above. You can just, in the exam, you can just write down one statement. And this graph clearly is symmetric with respect to the y-axis, because if you fold it along the y-coordinate, y-axis, the right piece is identical to the left piece. So the graph is symmetric with respect to the y-axis. Symmetric with respect to the y-axis. Okay? Let's see the 46. 46. It's like this. It's 0, 4, -4. So you check. You just go to the. You just check your electronic version of a textbook and see. So this is number 4. This is number -4. So this graph, we will see the x-intercepts are -4, 0, and 4. Y-intercept is 0. This point, it is on the this is origin. It's on the graph, so it is x-intercept. It is also the y-intercept, because origin is the intersection point of x coordinate and y coordinate. So it has x coordinate. It also has y coordinate. Okay, and you can see that if you rotate this right branch 180 degrees, you do have the left branch. So the graph is symmetric with respect to the origin. Okay, it's a symmetric with respect to the origin. That's about the symmetry, provided we know the graph. Okay, let's see the other one. Assume, let's see the 52. 52 has a following stuff. So we know this piece, and we know that the graph is symmetric with respect to x-axis. So you just go to check this problem. The problem says draw a complete graph so that it has a type of a symmetry indicated. This indicated type of symmetry means it is symmetric with respect to the x-axis, and you only know the half of the graph. Since it's symmetric with respect to x-axis, you're going to flip it to the bottom. So this is going to be a complete graph. Okay, so similar problem. If we have graph like this, half circle, and the indicated type of a symmetry is y-axis. Y-axis, you're going to flip it to the left. So you do have a circle. Assume you get a nice sketch. So you do have a complete circle. Okay, so this is the stuff. And let's check the other one. Says we're looking for the we test for symmetry. Test for symmetry. Let's try 70. Problem 70. Problem 70 is y equal to x to 4 plus 1 over 2 to x to 5th power, x to 5. Okay, remember, checked for symmetry, test for symmetry with respect to x-axis. Remember, x-axis, with respect to x-axis, x does not change. We replace y by negative y. We just change y to be negative y. Then let's check. Negative y is equal to, well, x to 4 plus 1, 2x to 5. Well, this one, there's nothing you can do, and it's different from the original one, so it is not equivalent to the original equation, so it's not symmetric. It's not symmetric with respect to the x-axis. Okay, check y. Test for symmetry with respect to y-axis. We replace x by negative x by negative x. Well, let's see, x by negative x. So we get a y equal to negative x to 4th power plus 1 over 2 times negative x to 5th power. Well, let's see what we can do. Negative x to 4th power, you have 4 copies of a negative sign. They canceled, so you will have x to 4. But at the bottom, 2 times negative x to 5th power, you have 5 negative signs. They cannot cancel. So there's a 1 negative sign survived. So this is the simplified version after you replace x by negative x. And this one clearly is different from this. So it is not equivalent to y equal to x to. When we say not equivalent, means it's not look like this one. We do not solve equation. We just simplify it and check if you can really get it the original. It's not equivalent to it, so it is not symmetric with respect to the y-axis. Now the third one, test for symmetry with respect to the origin. Okay, so how do we do that? We replace x by negative x, y by negative y. Okay, well, let's check y by negative y. So y becomes negative y. X becomes negative x, so it's negative x to 4th power plus 1 over 2 times negative x to 5th power. Well, let's simplify. Remember, this one we already did the simplification. We get x to 4 plus 1 over negative 2x to 5. It is negative y equal to this. So we multiply two sides by negative 1. We can cancel them. So this is again, this is not to solve the equation, we just simplify the additional pair of negative sign. Okay, so this one is equivalent to the original one, and this one is exactly, it's equivalent to the formula after we do replacement, and it is exactly the original one. So it is equivalent to this. So what we are going to say, it is symmetric. We mean the graph is symmetric with respect to the origin. That's good. At least we find one symmetry. It is symmetric with respect to the origin. Very good. Okay. Excellent. So let's do more exercise. Let's see the 76. For 76. 76, the question is, if the point negative 2b is on the graph, of 2x plus 3y equal to 2. What is b? Okay, so if you have a point with a coordinate on the graph of certain equation, we're looking for the unknown coordinate. Basically, you just plug in, because that's the meaning of a point on the graph. The coordinate will satisfy the equation. So it's 2 times here coordinate x is x coordinate, negative 2 plus 3 times y is b. 3b is equal to 2. Is equal to 2. This is the equation. Well, let's see. Negative 4 plus 3b is 2. So 3b is 6 and b is 2. So this is the value of b. See it? So a point is on the graph if and only if the coordinates of the point satisfy the equation. Here is what I mean, satisfy the equation. Okay, and one more thing, you see here, if you have a symmetric point, you see, assume this graph is symmetric with respect to y-axis. This is a x-intercept. Of course, negative x is also the x-intercept. Okay, understand this? So the x-intercept for the symmetric graph with respect to y-axis is always paired. You have a negative, you have 6, you will have a negative 6. You have 2, you have a negative 2. All right, so problem 80. If the graph of an equation is symmetric with respect to the y-axis, and 6 is an intercept, x-intercept, name another x-intercept. So if 6 is an x-intercept, then negative 6 is another x-intercept. Okay, so this is always paired because it's symmetric, balanced. This one is on the ground. This one is also on the ground. Okay, so you see here, there are many interesting exercises, and I did some of them. I do hope you to do the other exercise, recommended one, and make sure you understand the problem. And this is about, you see, symmetric with respect to y-axis, the x-intercept are paired. if it is symmetric with respect to the x-axis, this way, then the y-intercept will be paired. And this will be the 8A2. Okay, 8A2. If here's number 2, then this one. -2 is another y-intercept. Okay, and check this 8A2, see the whole complete question. This is the answer. Just because of this graph, you need to connect the graph to the definition, algebraic definition. Okay, this is symmetry with respect to x-axis. Y-intercepts are paired. If it's symmetric with respect to y-axis, x-intercepts are paired. Okay, so we finish this section. This section is very computational. So you may have many computation. Try to understand the computation and try to understand the symmetry. You will use them in the future. Okay, we finished today's lecture. Thank you.